Good morning. My name is Viva Cunliffe. I work with the hydroxyl radical and mitigation with my company Reduction Tech. We are offering the release of the hydroxyl radical as a simulation of a great oxidation event, which I've talked about on our channel. I want to talk today about something that departs a little bit from the peer-reviewed literature on the hydroxyl radical. I base pretty much everything that I tell everybody else on what I've read in the peer-reviewed literature of the paleogeology field or the current atmospheric chemistry field on the hydroxyl radical publications. But one of the things I've noticed is that there certainly is a very intelligent design going into chemistry. And I think there's a big difference between chemistry and biology when it comes to the whole idea of intelligent design, because we can get lost in the idea that biology can be random genetic deviations that are spontaneous. But in chemistry, when you have systems that are making a lot of sense and creating homeostasis, I've come to believe that there is intelligent design behind it. So anyway, with the hydroxyl radical, I think there are three levels that it operates at. And I think that this is the part of the intelligent design that's very interesting. We have level one, which is the pre-industrial levels of hydroxyl radicals. We have the level two hydroxyl levels, which are industrial, which is where the pollution precursors to ozone trigger ozone, which then is the mother of many hydroxyl radicals in the troposphere, which steps up the pollution protection at that level, which I think is extremely well-crafted design. And then level three is inundated. So we'll talk a little bit about level three, because I think this is what we have to actually come together as a science community and define about the hydroxyl radical, is whether or not it's inundated. So again, ozone breakdown is the mother of hydroxyl radicals. And what's happening here is that from a broken O3 molecule, there's one ozone atom that breaks off. It's called an O1D, just to identify it. And it exclusively pretty much reacts with water in the atmosphere to form a doublet hydroxyl. And this is where we get our cleansing. So the nice thing about this chemistry design is that about 22% of the hydroxyl is recycled overnight as through different intermediates and daughter molecules. The overnight cycle creates nitrous acid reservoir of hydroxyl that is triggered again by sunlight. So very intelligent. And again, more pollution triggers more ozone. And this is where I think our atmospheric chemistry field is getting a little tripped up, thinking that, that hydroxyl will always be there. It's not. It is now, I think, inundated, and I'm going to explain why here in a moment. And I think that because of the adaptability of this molecule, scientists haven't spoken up about our pollution levels as much as they could have. But I think that's going to change dramatically now that we are being clobbered over the head with a climate disaster. So here we have a slide on the sources of ozone precursors, and this includes nitrogen oxides from different destabilizing events that happen in the Earth system, like volcanoes, ocean processes, biological decay, and lightning strikes. And of course, human activities have added another 24 million tons of nitrogen oxides to our atmosphere annually. So you know, high temperature combustion, I believe that the universe architects probably didn't know that the fossil fuels that they installed in the planetary reserves that we're exploiting would create a lot of high temperature combustion once we industrialized. Anyway, this is sourced from the web, and I list the source there. Hydroxyl is now inundated, in my opinion, and I put that out for scientific review everywhere. And the two criteria that I'm offering is that as soon as we moved from steady methane levels to accumulating methane, I believe that this indicated that hydroxyl has become inundated. So further to that, correlating record levels of all pollutants cross-verify this inundation state. So I think when you have these two data points in play, that we have a hydroxyl inundation, and I would put that forward as a definition that I think we need to be discussing. So again, for people who don't know this about the hydroxyl, it is natural. It's made by sunlight, a couple of different routes, but mainly by the breakdown of ozone. And we have to remember that when we're looking at something natural and a mitigation process, that what we're doing is working for a return to a factory clean air setting, which I think is the best choice. So for example, you know, the physics of removing heat trapping compounds to initiate cooling is preferred to particulate-based shading, such as solar radiation management, simply because of air and environmental quality. So because we have living beings on this planet, we really should totally try to minimize the aerosol masking effect, the shading we get from particulate matter. It's a lesser wisdom when it comes to planetary cooling because of the living beings. And also the total removal of all constituents from the atmosphere that block the release of heat is known to be the fastest route to global cooling. And here's a peer-reviewed paper graphic that is very clear that removing all greenhouse gases simultaneously with something natural like the hydroxyl, and there really is, I have looked, nothing else is twice as fast and twice as effective as any other technique that we're currently discussing. So again, for those of us who are working and studying the geoengineering field, this is not geoengineering. And I think we have to really understand that when your mitigation is to bring something back to its factory setting, it is not geoengineering, it is mitigation. Anyway, thank you for your time, and I hope you have a lovely day.